Most cheap electronics have some kind of thermal protection system based on a cheap, simple device called a thermistor. A thermistor is a thermally variable resistor, a resistor that has a predictably varying resistance across a temperature range. High-end induction cooktops, dryers, and welding equipment might shut down or go into thermal lockout if they sense an overtemp condition. CPUs or GPUs might underclock or skip cycles as their temperatures rise. Battery power tools or cell phones may go into low power mode if their batteries experience excessive heat. Electronics without many mechanical components or high voltage circuits have the advantage of being able to integrate a single thermistor directly into the chip or heatsink, getting a reading that is pretty close to the maximum temperature experienced by the system. Deciding where to place thermistors is not as easy in mechanical systems or welding equipment with high amperage resistors on printed circuit boards. This is something that manufacturers are still actively struggling with. I've opened up a lot of dryers with scorch marks because they placed the thermistor in the drum exhaust instead of in the heater output. I've also opened up a lot of welders with burnt diodes or inductors because they placed the thermistors in a transformer or in an 8-pound glob of silicone on a plastic wind tunnel housing. If the hottest or the most temperature-sensitive components aren't being directly monitored, then the temperature monitoring isn't going to do anything. Just because your device claims to have temperature protection doesn't mean that the temperature protection circuits are actually doing anything. Don't trust manufacturers to properly locate thermistors. Your equipment can still catch fire and or explode even if it has a thermistor. Don't put organic liquids in your dryer and pay attention to the rated duty cycle on your welder.